All right, so welcome in. These are the questions for the impulse and momentum sample problems on Canvas. You already have those in front of you, so I'm going to just jump straight into them. Which of the following objects have momentum? But that momentum relies on mass and velocity. Well, every object is going to have a mass, but not every object has a velocity. So if your velocity is 0, then you have no momentum. And there's some keywords in here, such as if it stopped, at rest, and so on. So if v is equal to 0 meters per second, there is no momentum. If you're moving, whether at any kind of speed, constant speed, or increasing, as long as you're moving, you have momentum. Even that electron that has such a tiny mass, it still has mass. So the correct answers are, for this one, the electron, the compact car, and the small fleet. Number 2, in order to catch a ball, a player naturally moves his hand back in the direction of the ball's motion. This habit causes the force of impact on the player's hand to be reduced because of what? Well, by increasing the time of impact, you reduce the force felt, just like your car collisions and everything else. So the time of the impact is increased. Remember that is J is equal to Ft, and you're going to have the same amount of J or impulse regardless. So if you want to reduce the force felt, then it's got to be increased time. Number 3, what's the speed of a 4 kg object with a momentum of 12 kilograms per meters per second? So we're looking for velocities equal to our question mark in meters per second. And we've got a mass of 4 kg, and we have a momentum of 12 kilograms per meters per second. So our equation is going to be P is equal to mv. Substitute our values of 12 is equal to 4 times v, divide by 4 on both sides, and we get velocity is equal to 3 meters per second. Number 4, what is the time that it takes for the ball to stop? So we're solving for time, t equals question mark, and we're going to go ahead and write down our variables. Now, we've got 720 grams, and that is not in kilograms. So pay attention to your units. It's got to be in kilograms. So mass is actually 0.72 kg. And the way that works is, remember, if you got any kind of grams, here's 720, and your decimal's out here. So you're going to be dividing by 1,000, or you can move your decimal back 3 spaces. So 1, 2, 3 to the left, and there's your new decimal place. So you've got mass equal to 0.72 kg. Okay, it's traveling at 15 meters per second when it is caught. So before it's caught, it's 15 meters per second. After it's caught, well, it comes to a stop. So VI is your 15 meters per second, and VF, your final velocity, is 0 meters per second. And we have a force that is 520 newtons. So F is equal to 520 newtons. Looking at our big equation, number 19, it's going to be J is equal to Ft is equal to M times the sum of Vf minus Vi is equal to delta P. Well, based on the variables that we have, we don't need to use every single portion. We just use what we do need and what we have. So we've got Ft, M, Vf, Vi. So we are looking at this middle portion right here. This is all we need to use. So I'm going to go ahead and substitute my values. We had the 520 for force, so it's 520 times what we're solving for, so T is equal to our converted mass of 0.72, and our final velocity was 0 minus 15 for our initial velocity. So when you multiply these out, you get 520T is equal to negative 10.8. You divide by 520 on both sides. Now these cross out, and T for this, even though it should never be the case, because there was its final velocity minus initial velocity making this negative, T comes out to be negative, but time can't ever be negative. So if you ever get a negative answer, make sure that you just make it positive. As time, we can't ever go back. So time is always positive. So our actual answer is going to be T is equal to 10.8 seconds. Number 5. All right, number 5. What's the impulse? So we're looking for J. So J's are unknown. The units for that is newtons times seconds. And we got a force that caused the acceleration. So F is equal to 80 newtons. And the mass is 5 kg. And we've got the object goes from 2 meters per second, that's our initial velocity, to 8 meters per second, that's our final velocity. So VI is equal to 2 meters per second, and VF is equal to 8 meters per second. So again, we're going to look at our full equation. J is equal to FT is equal to M times VF minus VI is equal to delta P. And now, based on the variables that we have, we need this part and we need this part. So we're going to use those and set them up to equal to each other. So we've got J is equal to M VF minus VI. All right, go ahead and substitute. So we're still solving for J, and this was 5. Now, keep in mind, there is a force, but there's no time, so that's why we're not using this at all. So the force is added info here that we don't need. So final velocity was 8 minus the initial velocity of 2. So J is equal to 5 times 6. So our answer is the impulse is 30 newtons per second. Number 6. What's the force on the cheekbone? So we're looking for the force that is felt by the cheekbone, and they've given us the impulse and they've given us the time. So we're looking at F as our unknown. We've got J, the impulse, as 150, and we've got our time as 0.02 seconds. Make sure that you punch these into the calculator correctly. So it is J is equal to FT, the first portion of our equation, and 150 here is equal to our unknown force times the amount of 0.02 seconds. So divide by 0.02 on both sides, and we get our force is equal to 7,500 newtons. All right, number 7. It says, what is the force exerted on the ball? So we're going to solve for F. Now we look at our information. We've got the mass as 0.18. So even though it's a small number, it's still in kilograms. It's good there. And it's thrown at 40 meters per second. So that's our initial velocity. And it's hit directly back in the opposite direction. So that's the key thing here. It's hit directly back in the opposite direction. So we're always going to assume that they don't tell us the direction, it's going to the right, which means the opposite is now left. So if it's going to the left, not only is this the final velocity, but it's also a negative value. So VF is equal to negative 55 meters per second. And the time of contact, T, is equal to 0.003. Again, these are going to be very small numbers, so make sure that you're paying attention to all the little zeros. So 0.003 seconds. And again, when we use our long equation, J is equal to FT is equal to M times VF minus VI, we only need what we have. And we have M, VF, VI, T, and F. So we're going to use FT is equal to mass times the sum of VF minus VI. Now, force is what we're solving for, so we're going to go ahead and write force. This was being multiplied by 0.003. Our mass is 0.18. Our final velocity, remember it's negative 55, minus our initial velocity of 40. So when you multiply this side out, we get negative 17.1. And this part is still 0.003. So we're going to divide by 0.003 seconds on both sides. And our force comes out to be negative 5,700 newtons. And this makes sense because the force causes it to go to the left, so that's why you have a negative value. So number 8, we're looking for J, that's our unknown. And our mass is 0.540 kilograms. And our initial velocity is moving forward with a speed of 18 meters per second. So VI is equal to 18 meters per second. Then it rebounds with a speed of 13.5. So it hits the wall, comes back. So rebounds with a speed of 13.5 makes it a negative value. So our VF is equal to negative 13.5 meters per second. And our time of contact, T, is equal to 0.250 seconds, or you could just say 0.25 seconds. So we're looking at our full equation. J is equal to Ft is equal to M Vf minus Vi is equal to delta P. Again, based on what we have, we need the J, and the rest of it is over here. So we're going to set these two as equal to each other. So J is equal to M Vf minus Vi. Vf was negative 13.5. And our initial velocity was 18, so it's minus 18. You multiply those out together, and we get an impulse of negative 17.01 newtons times seconds. Number 9 is a continuation of this problem, and this one asked for determine the force of the wall on the ball. So for number 9, we're looking at F as our unknown. And we have the time of contact was 0.250. And we have everything else here as well from the previous problem and including this one. But the key thing that I'm trying to get to is that we've already found the impulse. So all we need is the J value. And you can go ahead and put that down from our previous answer of negative 17.01. So now we see that we can use this portion as J is equal to Ft and solve for our answer. We could have just gone back to doing this again, but that's useless because it's adding too much to it. So J is equal to Ft. Our J, our impulse, was negative 17.01. And force what we're solving for, and our time of contact was 0.25. So divide by 0.25 on both sides, and our force is equal to a negative 68.04 newtons. All right, finally, number 10. Tennis ball initially at rest, hit by a racket with a force of 100.8 newtons, and leaves with a velocity of 33.6. The time of contact is 0.20 seconds. What's the mass of the ball? So ultimately, we're solving for M. That's our unknown. And we've got initially at rest, which means Vi is equal to 0 meters per second, hit by a racket with a force of 100.8. So F is equal to 100.8 newtons. And it leaves the racket with a velocity of 33.6. So it's at rest, and it leaves in that direction. We're going to assume to the right, so it still remains as positive. So Vf is equal to 33.6 meters per second. Time of contact, T is equal to 0.2 seconds. So again, I've done this equation plenty of times, so I'm just going to write what we need. Ft is equal to M Vf minus Vi. Our force is 100.8 newtons. Our time was 0.2, and that's equal to our unknown mass, with the final velocity being 33.6 minus our initial velocity of 0. So when we multiply this side out, it's going to be 20.16 is equal to mass 33.6 minus 0 is 33.6 still. So divided by that value on both sides, and our mass comes out to be 0.6 kg. I hope this video was helpful in terms of solving all these problems. Have a wonderful day.